Welcome back to iTakeOn conference. We talked about a lot of things related to architecture in these 2 days. We talked now with the last 2 talks were about architecting data, but before that we discussed about organizing people along with architectures and about the trade-offs that you find in software architecture. And yet there's one common theme that I think was discussed again and again, and that is about cloud computing. Cloud has become such an important part of our architectures nowadays that we can no longer avoid talking about it. We need to discuss it. And that's why I find this last session very interesting, because we have rules for clean code, we have some rules for clean architecture. Perhaps it's time to think about rules to have clean cloud. And to talk about these rules, we have with us Armagan Namchalar. He's software architect, public speaker, mentor, lecturer. I also know, because we had recorded a very long conversation once again on YouTube. He's also a musician, he's also an electrical engineer, he's also fascinating by brain science, and so and a leader in in many organizations where he hired people and created very nice cultures, engineering cultures. And I have worked with him in the past a couple of times, and it's always been a great pleasure. I'm so happy to have here with us Armagan Namchalar. Welcome, you have the stage.
Thank you very, very, very much. Thanks a lot, Alex. This is a joy. I'm very excited. I don't know how to start. I don't know how I'm gonna present this talk. I'm very excited to be here. So apologies first if there are any mistakes or if this is a little bit annoying. I know the time is late. This is the last talk of the conference, of the day of the conference. So, just wait 45 minutes more, and then we're all going to be relieved, finally. I'm just kidding. It's a little bit, the day was a little bit tiring. We're all, I guess, a little bit tired. So I think I'm going to try to not to bend your mind with this talk so much. Today, I'm going to talk about clean cloud, but just right now, I mean, like a couple of minutes ago, I noticed that clouds are usually loaded with water, and the cleanest cloud is probably the one that doesn't exist. So pardon the pun. I believe cloud exists. I believe clean cloud exists. And today we're going to talk a little bit about that. I am Arman Amjalar, and Alex did a great introduction, so I don't have much to say other than I'm leading a company called Coyotive, where we create new engineering talent. We create new software engineers. We mentor existing ones. We mentor organizations and startups and CTOs, and we provide software architecture and software development services as well. I am active in the open source community. I'm active on GitHub. Most of what I write in my life is open source online on GitHub, and I have stuff that ranges from microservice frameworks to UI frameworks to brain signal processing algorithms and applications. And that last bit is a little bit mind-bending, but we'll leave that for a different time. I think 2 years ago or 3 years ago in iTake, I think I presented a brain signal processing application, but yeah, it was fun. All right, let's talk about the problem. Let's start with the problem definition. If you have been in the business for 10 plus years, maybe 20 years, you're going to remember sentences like, we're using procedural programming, we have to use OOP, it will solve all of our problems. Or our problem is that our code is not modular, we have to break our code into modules. And I grew up with these things. I heard these things, I said these things myself. And then about 10 years ago, this kind of evolved into something else. It evolved into, our problem is that we don't use the cloud. We have to use the cloud, and all of our problems are going to be solved. And then we started using the cloud, and nowadays it's like, our problem is that we're not serverless. We have to do serverless. And this thing never ends. The last I heard, I think last month, some CTO was saying that we need to move to Cloudflare workers. That's going to solve all of our problems. So I'm going to get to this part, but we're clearly in need. And let's accept that cloud is a new field for all of us. We don't yet fully understand what it's capable of, what we can do with it, and even how it truly operates, and what are the best practices of the cloud. And every single day there's a new framework, there's a new library, a new product from a cloud service provider, a new way of doing things, a new architectural approach to building cloud applications, or a platform, or a new infrastructure that's coming up. And last time I checked, and that is this morning, AWS was offering 21 different categories of products. AWS was offering 21 different categories of products, and for a total of 245 products. That's a cloud service provider giving you 245 different tools to build your applications. Now, of course, I hope they haven't released one today, because it's really difficult to check. In comparison, Google Cloud has 175 new products. Sorry, 173 new products. And I'm not sure if that includes the last product they released in Google I/O this week. So most of these products are released in the last couple of years. They are new, they're rapidly growing, and they try to stay backwards compatible. They don't guarantee backwards compatibility. They are willing to guarantee compatibility with their other products. Most of the time you hear sentences like, yeah, we have that product and we have that other product, but currently there's no coherence between them. They just don't work. You have to bind them manually. There's no automatic way to make one work with the other, even though they're coming from the same cloud provider. The thing is, how can you even remember the names of these products, let alone design something based on an informed decision about them, which could, resemble the first steps of the first assembly of something what we can call an architecture? It's very difficult. And I want us to talk about this today. This talk will not teach you a recipe for success in the cloud. It's not going to give you the best practices of cloud architectures. I actually have many other talks on kind of a similar topic, service-oriented architectures, microservices, cloud architectures, observability, how to have a cloud system online, including the one I did last year at iTake on conference. And we also had multiple people talk about cloud architectures in this conference. So this talk is not that. This talk will not try to convince you to buy a product. It's not trying to convince you to subscribe to one. It's not going to pretend that, I'm not going to pretend that I'm standing here, I know all the answers to everything. And because I'm coming from the future and I have seen it all, and here is the best way you need to adopt to deal with cloud architectures. So this talk is a call to thinking, discussion, design, and friendly exchange between software architects. It's not even a call to action. This talk will present a concern we all inherently have about the cloud, and it's going to make sure that we can start talking about this. And maybe in the future we're going to come up with patterns that are they're going to pave the way for success. So this is a talk to underline a problem with a bold, big red marker. It aims to raise awareness about the direction of our industry, and it hopes to raise a couple of questions we should ask ourselves. And I hope you're going to keep thinking about the answers after this talk. All right, so we learned that good code matters ages ago, right? Since the 70s, since the 80s, since I was born. I was always like, these presented with some best practices. This is how you should code. We had books to teach us. We had teachers. We had established people in the industry to teach us. And companies rose on the premise of good code because it let them iterate fast and ship fast. And companies crashed as a result of bad code. The practice of coding, in the meantime, it almost became a commodity. Almost, the practice of coding. Tens of programming languages and frameworks later, we're still implementing the same concerns, the same business rules, the same business requirements, and we're still making the same mistakes. We're still talking about whether our computers are going to run out of disk space or not. This is still a concern in 2021. So even though the code we write day by day changed, the environments changed, the act of coding, the practice of coding, I fear, is being reduced to a commodity. Because the concerns we're addressing, they haven't changed much. It's just our interests have moved on, because I think we solved the software design problem, the software architecture problem. We kind of have a relatively good idea of what patterns we can apply at our code at whatever level it is. We kind of know the best practices about this. And, we introduced practices like TDD, extreme programming, and so on and so forth. I mean, does anyone even remember when test-driven development was new? It's so embedded in our lives right now. But today, what is interesting is not a new language. It's not a new way of doing things, because pretty much all languages right now give you the same set of features. Maybe, there are a couple of examples. There's a couple of exceptions to this, but pretty much all of the languages let you do anything you want in the cloud. We're not looking forward to a new language or a language feature. What we're interested today is a new cloud API, a newer way of doing things, or in other words, maybe the newest way of doing things, like deploying apps, scaling apps, observing them, connecting them together, testing them at scale in production by inducing chaos in our own systems. This is what we're interested in today as software engineers, as software architects. But let's pause for a second and take a break, and let's see where we are. Now, the question is, how does one know where they are? This is not a rhetorical question. How do you determine your position wherever you are? For example, GPS is a good example, right? It gives you some coordinates to determine where you exactly are in the world. And for those, it basically gives you numbers, two long numbers. But for those numbers to make sense to anyone and to be able for them to find you, you need something called a frame of reference. It is a coordinate system and a reference point so that you can tell where you are with respect to that reference point in the coordinate system. And then you can find where you are, and you can tell, this is the direction I'm going, and so on. The frame of reference that I'm going to use today is clean code and clean architecture. These are, as I believe most of you know, two prominent books from Robert C. Martin. And they are the staples of any software design library, book collection. And in talking about coding, the book Clean Code is a frame of reference I like to use. I teach it at my school to entirely new beginners, junior engineers, mid-level engineers. We go over it and try to understand what the book is trying to say. Now, it's not because I agree with everything Uncle Bob says in the books, but because it's a good frame of reference. It gives you a playing field, a vocabulary that you can use to talk about your ideas. It gives you, even if you don't buy into the arguments, even if you're like, this is completely wrong, I'm doing the exact opposite of this, and I'm very confident that my approach is better. What happens is it creates this this environment for you. It gives you these distinct concepts that you can play with, that you can raise a counter argument to. So these concepts basically let you position yourself and your thoughts with respect to themselves. This is why these books are prominent and are good to read. But before we move on, let's talk about architecture. How many kinds of architectures do we have? Now, this is a trick question because there are tons of kinds of architectures, and no two software architects can agree on their definition. But indulge me to talk about two main groups that I believe that exist: software architecture and systems architecture. Principles, testing. But this is all meant to produce software. This is meant to produce code. And this is meant to produce application code that runs to satisfy a use case, a business use case. Now, all of the software architectures you know and you apply, they have to interact with some sort of a system, at least one. It could be an API, an HTTP API, a gRPC API. It could be a UI, like the web or mobile or a data store. These are different systems that you have to interact with at all times. So there is a crossover somewhere. Now, previously, like 20 years ago, or maybe even 10 years ago, you had distinct people to do all of these things. You would have a database architect, a database administrator, a system administrator. You would have people responsible for the data centers that you're deploying your application to. And you would all work together on a solution. But nowadays, the lines are a little bit blurred. Look at your Twitter feed. Look at what you and your peers are discussing nowadays. Microservices, serverless architectures, queues, orchestration. We're talking about these concepts, and we're talking about building our apps with these concepts in mind. But these are not software. These are systems, external systems that we're using. These are mechanical tools that we're using to realize our application and our use case. So think about how your role has changed over the years. Can you actually tell any difference between software architecture and systems architecture nowadays? They're so tightly coupled together. And I'm sure some of you know tight coupling is not the best way of building software, but we're going to talk a little bit more about that later. The thing is, code is not only code anymore. It's code plus where it's going to be deployed, how it's going to be tested, how it's going to be scaled, how it's going to talk to its dependencies, how it's going to talk to other services, even how it dies and how it gets replaced by a new version and it's coherent with the other versions of other services in the system. So all of this is combined right now, and they affect the way you build code. So how does our existing knowledge help us in this case? Does it guide us? Does it prevent us from thinking of new avenues? Or does it give us enough leverage to make the best use of the cloud? Because we all have certain things learned in the past, right? We all learned software architecture, software design, object-oriented programming, functional programming, event sourcing, whatever. How do they really help us? Domain-driven design. I am a proponent of domain-driven design. I'm a proponent of microservices whenever you need them. And I'm one of those people who say, you know, they really align with domain-driven design, microservices. But is that actually true? Do we say that because we could prove that? Or do we say that because that's where our biases lie? Because that's what we knew before as the best way of building applications. And we're trying to bring it to the future with us. So, like 10 years ago, there was a manifesto called 12-Factor app. If you would like to refresh your memory, please visit 12factor.net and 12factor.net and read the manifesto there. I think it's by engineers at Heroku, and it was a step towards the right direction of where we are right now with the cloud. But the problem is, everything I talked about, including 12-factor application, they were put together in a time of control. Back then, when we were designing these systems, we had the control. As a designer, we defined what would go in and how they would interact with each other. We had control. We controlled the database. We controlled the underlying hardware. We controlled the network. We controlled the disks even, the databases would use. And most of them were proprietary systems. They were custom built for our needs, and we could change them as we wanted, even though not, you know, easily. But this meant that we could plan ahead because we knew what we had. We knew our capabilities. So we could design our software because we knew our options. But the problem is, there are hundreds of products on the market now to build your applications, and none of them are custom built for you. And I'm going to come back to this at the end of the talk. Most of them are barely experiments, let alone battle tested, fully featured, production grade services. They're almost built like startups within these cloud service providers. They're MVPs thrown at the user's expense. And they are being developed while the users are discovering the limits of the capabilities of these systems. And I think this is the problem that we need to talk about. It's almost like the pharmaceutical industry, except this one is not regulated. And, you know, we have certain needs that we need met. There is a lot of advertisement going around, a lot of success stories. Like, I took this pill, this magic pill, and it fixed all of my problems. And we're like, please give that to me. I need that. And there are no regulations. It's out there. You don't need a doctor to prescribe it for you. And therefore, these cloud services claim that they're solving all of your problems. Or, you know, if you buy into them, if you take these set of 10 products, they solve all of your problems. But when you switch over, you might have like an increase in productivity, let's say, but it becomes too late when you notice that they don't actually solve all your problems. You hit their limits really fast, and then you try to get enterprise support, if that word is familiar to you. So why is this happening? Again, this is happening because we have needs that we cannot meet ourselves right now. We have to act fast. The market is changing. We can't deal with manual deployments anymore. We can't tolerate downtimes anymore. We have to be present in all geographies with instant responses. So we cannot tolerate service outages. And we operate, or at least hope to operate, at such huge scales that millions of people will use our apps, maybe simultaneously. And we're going to operate at such transient loads that we don't want to pre-allocate hardware to our apps. But we know one thing for sure: we have this need that it needs to be met. In a way, like a developer in the past, we don't want to deal with any of this. We just want to write code. That's why we turn to cloud providers. Like, please give me one magic, the holy grail of services that's going to solve my problem. That's what we're saying. But and you know, they appear just in time. They give you the magic pill, like, hey, would you like to take this? It's a great pill and it's going to solve your problems. And we take it. But this turns us into acting reactively. Everything works. We take the pill, everything works, until they don't anymore. And we have a new need, and then we also need to react to that. But for that, we need to find a new solution, which almost always requires us to ditch the previous solution. And we're always reacting to our needs because we cannot plan ahead. And basically, this is the root of our problems. This means that we're giving control away. And we're giving away the control of our software. We're giving away the control of our architecture. We're giving away the control of our future. You don't basically have any time anymore to stop and think and design and do architecture because there's just not enough collective knowledge to guide you. We have a lot of talks, but you know, take any pair of cloud tools, cloud services you use, look for a problem on the internet, you're not going to find it because maybe you're the first team to try to combine them. And you know, there's nobody who has explored the quirks of their integration. And these are not open source tools. You cannot change them. They are provided by the cloud providers. Now, I'm going to talk about the tale of two startups, or 20. This following part is based on a true story, based on conversations, sessions that I have with a CTO at a new startup. And I'm sure I say a tale of 20 startups because I'm sure this is exactly the same in other companies as well. So there's this new cool startup, and they want to be in the market fast. The competition is strong, and they want to make sure, the CTO wants to make sure that their co-founders are happy. They never complain about the software. They never complain about, blame the engineering team or the CTO about anything. The software should be perfect. If the startup fails, it should fail because of the business. This is what the CTO wants. So this basically means that they cannot use VMs. They cannot manage their own servers. They cannot use EC2. This means they cannot use Kubernetes because it's too complicated. Who's going to manage all of those YAML files anyway? It's a headache to set up. It's a headache to remember. It's a headache to scale up in the team, not in the hardware. They cannot have any fixed databases because they cannot maintain it. It's too complicated. It's too complex. So they go with Firebase, which is a data storage as a service offering from Google Cloud. And they go with a serverless architecture because they don't want to deal with servers. They don't want to deal with deployment problems, etc., etc. It's great. Functions as a service, works perfectly with Firebase. They implement their MVP as 10 functions, and it's very easy to develop. It's very easy to deploy. It's very easy to understand what's going on. They have pop sub events. They have streams. They create through the UI by clicking on things, and everything is working perfectly until it doesn't. Cold starts are a problem. When your app is scaling up or down, you have to wait for up to a second, couple of seconds. Customers are waiting for a long time. You scale the team. They scale the team up to 10 developers. The developers are now fighting over what makes a new function in Cloud Functions and what not. They have over 300 functions. Deployment takes 2 hours, and when there are 20% in the deployment, there are version discrepancies with the previous functions, and it just does not work. So they have to take extra care to balance that out. And then they have new data, they have new business cases, they have to migrate their data models. And then they need multiple staging environments because they now have a dedicated QA team. They want to be able to test the software with different set of data before big releases. They need to react. They are always in the reactive mode because they designed for the bare minimum with whatever tools they saw was hype or cool. They put themselves in a reactive position. Now, they switched to combining those functions to containers and deployed with Google Cloud Run. They were only using one language anyway, so not a big deal. Who cares? It's actually even easier to read the code because it's now you can reference functions. It's easier when two functions depend on each other, and so on and so forth. Deployments are really fast again, but it requires you to change your domain structure, or requires you to manually configure an API gateway because Google Cloud Run does not support multiple services under one domain. Or under a URL. It has to have subdomains. So you have to change that now. You have to introduce another cloud service. Cold starts are still a problem. You haven't solved that. You need to react to that. So you try to hack your way around Google Cloud Functions and Cloud Run, try to integrate them so that cold starts don't work, to no avail. You finally switch the front end to Cloudflare Workers, which doesn't have cold starts, so at least your front end is very responsive, highly responsive. It's very close to your customers, so it's not annoyingly slow. By this time, your data models are duplicated everywhere, and they're out of sync with your data storage because they were highly denormalized in the first place. So you don't know which version of an entity is the latest. There are bugs you only find in production because an old user's data is, well, old, and it doesn't match your current model, and you couldn't find it because you don't have that old model anymore in your tests because you have upgraded your tests. So you need to react again. You bring in Cloud SQL. It comes with all the bells and whistles of SQL, but your data models were never separated in the first place because you were executing so fast. Now you have to rewrite almost all of your business logic because they were depending on Firebase. Now they have to switch to Cloud SQL. This story isn't finished yet, and I am following it closely, and I'm trying to help, but I know they're not the only team struggling with this, and hence we're having this talk today. What are we going to do about this? Let's go back to our frame of reference. This graph is from the book Clean Architecture, or rather a blog post from Robert C. Martin titled The Clean Architecture. I'm sure it's a very familiar picture to most of you. Like on the outer circle, you have devices, you have web, you have UI, you have your database. These are the mechanisms that you're using. These are the services that you're using. And then you have your controllers, you have your presenters, you have your gateways, your APIs. Then inside them, you have your use cases. This is where your application business logic rules. and at the center you have your entities. This is basically pretty much an overview of all the software architectures that we operate with until the cloud. But see where the database is. Superpose this image with the story I just told you. And Firebase is supposed to be on the outer skirts. And Cloud Functions are also supposed to be there. But your code is in the entities, your business logic is in your use cases and your entities. So there are at least 2 layers separating you from those tools. Are we actually doing that? Or are we tightly coupling ourselves? Are we moving everything we have out to the outer circle? What do we know? We know we have something called single responsibility principle. Does it apply ever to clouds? Can we talk about single responsibility principle in cloud functions, for example, in a serverless architecture? Your code needs to change only for one single reason. If you want to change something in a piece of code, that's fine, that's great. But if there's another use case, another requirement that wants you to change the same piece of code, then you should split them out. That is because violating the single responsibility principle. How are you going to do that with your functions as a service? That depends on your Firebase data store. And when you want to switch over to Cloud SQL, you need to change every single thing in your environment to make that happen. I'm moving from on solid principles from S to D, dependency inversion. This is something I really love in software architecture that we don't really apply in new projects anymore, and I feel the need to do that more. But I think this is something we need to take into account seriously, very, very seriously. This is something we have to apply to all of our cloud applications. In the cloud era, this is called design by contract or contract-driven design. You're inverting the dependency. The consumers are declaring the contracts, and then the providers have to match those contracts. And you can kind of automate a lot of the stuff, a lot of the dependencies, and a lot of the automated checks to make sure that you have a system that is stable and running as you design. So dependency inversion is a principle that we have to remember and bring back. We're currently not doing it, and I implore you to check the keywords here. There is another concept in the books called screaming architecture. When you look at a system, when you look at an architecture, it should scream at your face about the business use case. Like if you're building an app for online collaboration, the architecture should scream online collaboration. An architecture is not about the tools that you're using. It cannot say serverless, I don't know, event streams, S3 object storage. It cannot shout at you like this. CSVs, they don't mean anything. They're just the tools. When you look at a system architecture, it should scream about the use cases it's trying to solve. And this is something we're not talking about enough, because we're very excited about these new shiny tools that we're supposed to use to build our apps. And I need to say it again, frameworks, tools, they are there for you to use. If your architecture is based on the tools, like I'm using Hadoop and I'm using Kafka, it's not based on your use cases. Those are the mechanisms of communication. Your code should be completely separate from all of those concerns. And it should still function. Can you do that? Can you take the essence of your code and make it work? on your local environment without any of these specialized tools. If not, then we're failing as an industry. Cloud is a detail. This is something I'm putting on the table. The books mention that the databases are a detail. This is very famous, you'd know. The web is a detail, frameworks are details, no one cares. You should be able to swap them out easily. You should build abstractions on them so that you don't have to worry about them later, and you can easily switch from one vendor to another one to combat vendor lock-in. But the problem is way bigger than vendor lock-in. So that's basically what I'm here to tell you. Cloud is a detail in your software architecture. I want to finish with this concept of asymmetric marriage. In the book, again, Clean Architecture, Uncle Bob says the relationship between you and the framework author is extraordinarily asymmetric, and swap framework author with the cloud service provider. You must make a huge commitment to the framework, but the framework author makes no commitment to you whatsoever. They don't know about your use case. They don't really care about you. So, you know, if you can, if it's possible, make sure you have a way out in that arrangement, and don't really go deep into this asymmetric relationship. This is all about getting control, and this presentation I built to give you this frame of reference. You need to get control of your software, of your architecture. Thank you.
Thank you so much, Armagan. As always, a very insightful talk. And there are many things that come to my mind. There are not yet questions from the audience, but we can still wait a little bit. One thing that I think is difficult to do without cloud is whenever you deal with things like big data or machine learning, or things that, yes, you can do, let's say, minimalistic on your own computer, but whenever you get into big data, I don't see how you could get out of there very easily.
You can't, and that's the point. I think cloud is like COVID. It's here to stay with us. We have to learn how to live with it. All I'm saying is we need to vaccinate ourselves so that we know how to deal with it. Otherwise, it's going to take control of our body. We have to show it that we are in control. And yeah, our industry is moving at a breakneck speed, and we just can't follow it with our own tools. This is the right direction as long as we are in control.
Yeah, and there are definitely a lot of advantages. I think it's, as the theme of the conference was understanding the trade-offs for everything that you do is very interesting, very important. I have experimented recently, and actually I think for a few months now, we are running loads in serverless, and it's great, but I always approach this as I'm writing a Python application that I can deploy in a Python web server if I want to, but then I port it to serverless and it runs there, but I know I can always go back to
exactly and that's the beauty of it. That's what control means.
Okay, one question came up. Cloud should be a detail, but we should really gain a deep understanding of its stakes and how to deal with it properly, just how we learned to master programming languages. Would you agree?
I do agree. I think this is from the art of war. You have to know your enemy you're fighting. You have to know them very, very well to win. And cloud is here. It's great. It's serving us, but we have to master it. And I'm happy that we're doing this. Like, I'm not against it. I love it. All of my applications are in the cloud. I I'm a proponent of microservices. That's what I do for a living as well. But yeah, we have to master it. We cannot be reactive to all the new technologies coming up.
Yeah, and I have to say it is a bit overwhelming. I watch
Yes.
AWS, and like there's more and more services, and it's so and I just follow one of the cloud providers because that's the one that we are using. But imagine if you are to follow all of them. It's like it's almost impossible. That would be a full-time job.
Impossible. Yes. Yes.
Okay. Chaba is asking another question. Why is being reactive bad? Isn't this what Agile promoted? Instead of big planning for an imaginary future, we are reacting to client requirements fast.
Perfect question. This is the entire objective of this talk, to initiate this. Being reactive is bad in this scenario because we don't know the tools we're working with. In the Agile scenario, in Agile Manifesto, we were settled software engineers, software architects. We knew our tools. We were saying that there's a better way of doing this. We know there's a better way of doing this. Let us do that. That was the outcry of the Agile Manifesto. Here, the stakes are different. We don't know the tools yet. And they are being, created anew. All the cloud providers are showing like hundreds of products at us. That's why being reactive is bad, because we're not in control. Whenever we need something, we don't know the answer. We don't know how we can solve it. We have to go to our cloud provider and see their list of solutions and Google it and ask them. And then we're like, okay, maybe that's going to work for my use case. And you cannot find any books on this. You cannot find any real world experiences on this that people are sharing because no one tried that before. It's very, very limited compared to what we had before. That's why, being reactive is great if you know your tool set and if you can immediately come up with a solution because you know that it's going to scale. You did that before multiple times. It works for you. Being reactive is not that great when you don't know what tools you're going to be presented with.
Yeah, I think you are absolutely right, because there are two things that annoy me a lot with AWS. One of them is that it's very hard to figure out the right permissions for anything. Like I think it's the most complicated problem in software engineering today, figuring out what would be the minimum set of permissions for AWS services. But the second one is, whenever I search for documentation about AWS, everything is outdated. It is amazing how much outdated, because it moves so fast that you only get very outdated information. Well, not very, but outdated enough so that it's annoying.
Exactly. That's exactly what I feel as well. We are not in control. We're at the mercy of cloud providers, basically. They change a version. I deployed one of my services in Google Cloud Run in November. I wanted to do another deployment in January. It was a pet project. In January, they changed the way they deploy, and my service was not deploying anymore. And how am I supposed to know that? I spent like 6 more hours to fix it, to upgrade it to their new deployment system. This is not okay. Well, I think we need to talk about this.
One question popped up from Dora. Should we wait the cloud to be legacy to use it?
I think the solution is we have to force the cloud providers to work with us together to create standards that are extending beyond their platforms only. And there are certain initiatives in this part, like Cloud Native Foundation is trying a lot to standardize things. We're not there yet. And still, they see this as a business. That's the biggest problem. Software architecture 10 years ago, 20 years ago was not a point of business. It was just an idea that we people came up with and we were using. No one was benefiting if you use domain-driven design. No one makes money off of you. Maybe some consultants. But like every single CPU cycle, you spend in the cloud, make some money for a corporate, and I think that's what's pushing them towards this isolation of their products and not standardization. And in the end, I think standards will win and open source will win, and we're going to come up with enough standards that the cloud will be a commodity. Remember what I said in the talk, coding is now commodity. We need to raise coding again and push cloud to becoming a commodity for us. It shouldn't matter what orchestration tool you're using. It shouldn't matter what cloud vendor you're using. We're not there yet, but I wouldn't wait. It's very fun to be part of this, honestly. Even though I suffer a lot, I love it.
Yeah, me too. I mean, I complain about these things, but really, it's
Exactly.
been extremely helpful. And having the ability to not run a server full time and manage it and update it, and making sure that you
Yes.
have the right versions of all the libraries and runtimes that you need for everything, just for something that runs occasionally. That is,
Yes.
that's great. Thank you so much, Armagan. That's all the time we
Thank
had,
you.
and it's been amazing. If you want to listen to some more ideas from Armagan, as I mentioned in the beginning, we had a long conversation. It's on our YouTube channel, and we actually found a lot of interesting parallels between music and software engineering and leadership. It's been quite enlightening. Thank you so much. We are taking just a few seconds break and coming back with a closing.
Thank you.